Good morning. Today I will explain how to design the dipole antenna by using HFSS software. Okay. So before going to the design, we have to know the fundamental concepts of the dipole antenna. Okay. So in website, you just click omnicalculator.com. Okay. So if you give the frequency, at what frequency you have to design the antenna, just give that frequency. Automatically, the calculations will be done by the software. Okay. Now, I am designing a dipole antenna at 3 gigahertz. Okay. So what is the antenna length? Everything will be available here. See. So this is the general structure of the dipole antenna. Total length is capital L, and this length generally taken as small l. Okay, here they taken the small l. So you can see the structure of the dipole antenna in HFSS software. Okay, so this is the upper dipole and this is the bottom dipole, and here I am giving the excitation. Okay, and upper wire and bottom wire are PEC materials. Okay, I am assigning PEC material. Okay, so I am just considering cylinder 1 upper part and cylinder 1_1 lower one. Okay, and next after creating these two cylinders, we have to give the excitation. Okay, so here excitation is in YZ plane, so you have to select YZ. Okay, you just select the YZ and take the rectangle. Okay, and you can give the excitation. Okay, now I am taking XY, so this is the excitation. And next, we have to keep this entire dipole antenna in a radiation box. Okay, so we have to create one radiation box like this, and that was filled with the vacuum. Okay, this was filled with the vacuum, and you can see the diagram inside the radiation box. We can see our dipole antenna. So just go to I symbol and click A, so you can see the dipole antenna inside the radiation box. Okay, so you can click. Okay, here I just given some simple calculations how to design a dipole antenna. So here in this diagram, the total length of the dipole I am considering capital L, and upper wire and bottom wire lengths are taken as a small l. So the total length will be calculated by using this formula. Capital L is equal to 468 divided by F. We get in feet. Okay. Suppose I want to design an antenna at 3 gigahertz. So F is the formula of lambda. Lambda is equal to C by F. Okay. So you can get lambda 100 mm. Okay. And next, you have to calculate the total length by using this formula also. Okay. So here I am getting total length capital L. If you substitute lambda value and that will be multiplied with 475, then you can get in feet. Okay. And after that, you have to calculate the radius of this dipole. So generally the radius of dipole is lambda by 200. Okay. And upper wire length, that is small l or dipole length, you get by using this formula, L by 2 minus gap by 2. Okay, so here L is the total length. If you take off value, then you can get the small l value. Okay, and here we taken a gap because here we have to give the feed. So for feeding purpose, I am leaving some space, so that will be considered as a gap. Okay, so first of all, you have to upload these equations in HFSS software. So now I will explain how to upload these equations in HFSS software. So just go to HFSS design properties. Okay, HFSS design properties. Okay, and just click on the add. If you click add, automatically add property window will be created. So value, so just type lambda and unit type length, and if you give mm or feet or whatever maybe, just give mm and give the value here and just click OK. then automatically lambda will be added. Like that, I added all these parameters. So lambda is the direct value and radius. Okay, so radius, the dipole radius generally I already said lambda by 200. So just to type lambda by 200. Okay, after that, click OK and again click on add, and next parameter is radiation underscore radi. Okay, this is also we will use. Okay, underscore radius plus lambda by 4. Okay, and feed gap 0.5 mm, and total length of the antenna in millimeter I need. That's why the formula is 0.475 into lambda. Okay, and next you have to calculate the small l value, that is I am considering dp underscore length. So the formula for dp underscore length is considered as total by 2 minus gap by 2. Okay, and I am taking another parameter radi underscore height. So that is the value for radi underscore height is, this is the equation, gap by 2 plus dipole underscore length plus lambda by 10. So this is the formula of radi underscore height. Okay, once adding these local variables, so just click OK. So automatically the antenna values will be updated here by this software. Okay, now you can see, you can compare these values with the online calculator. Okay, so just to go to online calculator and I am giving frequency 3 gigahertz. Okay, so what is the length of the antenna? Here we are getting 47.5 mm. So in our HFSS software, so antenna length, that is I am considering as total. Okay, here we are also getting 47.5 mm. Okay, and next see the dipole length, small l value 23.775. so there also you get the same value, and wavelength 100 mm approximately. So if I want to design at 108 megahertz, so just click 108 and keep megahertz. Okay, 108 megahertz. See the antenna length here. Now you can convert it into feet. Everything can be converted into feet. Okay, so like that you can calculate the lengths for different. Okay, for 108 megahertz, antenna length is 4.3. Full length, that is the small l value 2.1 feet. Like that you can design the antenna by using online calculator. Now I will explain how to design HFS dipole antenna in HFSS software. So add all these parameters, create a cylinder. Okay. So cylinder window and click draw cylinder and leave it. Okay, this cylinder length is taken as so these are the dimensions of the cylinder one. So just write 0 comma 0 comma gap by radius radius, just type radius. These are the local variables we are taken, and height of the dipole dp underscore length, so 23.5 mm. Okay, and just to type these values and just click OK. So automatically cylinder one will be created. Okay, so this one will be created, and next take another cylinder. Okay, and give these values, or you have one option, that is just right click on the cylinder and edit, duplicate, and just click around axis. Okay, and this is the Z axis, and keep 180 degrees. We will see what will happen. Total number will be 1. Okay, we will see what will be happening. 180 degrees. Just click, right click, edit, arrange, or duplicate around the axis. You take y axis and 180 degrees, click OK. You can see exactly opposite another cylinder will be created. Okay, another cylinder will be created. Just I am deleting because I already created the cylinder. That is cylinder 1_1. Automatically bottom one cylinder will be. So like that you can duplicate the cylinders. Just right click, edit, duplicate around the axis, and take Y position and 180 degrees, click OK. So the cylinder will be created. So this is the procedure to duplicate the cylinders. Okay, and next you have to assign this cylinder with the PEC material, because I already assigned. How to assign PEC material? Just click on the cylinder, okay, and go to material and edit and type PEC and assign PEC material and click OK. Automatically PEC material will be assigned twice. Okay, and next you have feed. So how to give the feed for these two whites? Okay, just axis, okay, and take a rectangle. I am overwriting. Just click here and just click here. Okay, automatically one rectangle will be created because I already given. Just I am removing whatever the feed I am taking. Initially I am just removing and creating the new one. I am keeping the new one. Okay, and now how to give the feed? Just right click, assign excitation, lumped port, next, none, new line, and select the bottom part of the rectangle one. You can see the triangle shape. Just click there, and at the bottom also you will get the triangular shape. Just click there. Okay, you can get the defined option and just click next and finish. So automatically port will be assigned excitation. You can see. Okay, now change the YZ position through XY position. Okay, so simple dipole antenna will be created. Now you have to create the radiation around this. So just another cylinder. Okay, I already created. How to create a cylinder? Just click here and drop here. Okay, and make dimensions of those cylinder are this one: 0 mm, 0 mm minus radii underscore height. This will be 40 and height will be radii underscore height into 2. So you just type these values. Okay, automatically cylinder will be created. Okay, now you have to assign with air, name it as air, and assign vacuum. How we assign vacuum? Just go to edit and type here vacuum. Automatically vacuum material will be assigned. Okay, already we just click OK. So automatically another radiation box will be created. Created 2 cylinders. Those are assigned with PEC material. After that we created the radiation box, and between we are creating a excitation. Okay, and after excitation, just to validate the experiment, HFSS validation check. Okay, so in boundaries you can see the radiation, and next in excitation you can see the excitation port. Okay, now after validation you have to add the solution setup. How to add the solution setup? Okay, here I am validating experiment from 1 GHz to 5 GHz, and solution frequency I am getting. Take the setup one and see. Just I am deleting. Just right click, add solution setup, advanced and give from 2.99 gigahertz, and number of passes I am taking 17, and just click OK. And I am giving 1.4 to 4.485 gigahertz. Just click OK. Automatically solution setup will be created. And next you okay. So just right click, insert far field setup, and click infinite sphere, and name 3D. I already created. Just to create the 3D, and you have to change these values, phi value and theta value. So here I am given 3D minus 180 to 180 and step size 1, and star theta 0 to 180 step size 1. Okay. And p underscore plane, I am taking minus 180 to 180 theta value, and step size will be 1. Okay. So I am taking these two radiation planes. Okay. And next click validation check. After that you just analyze the experiment. Okay. So it will take some time. Okay. So after completion of the progress, you can see here normal completion of simulation on server. Okay, you will get the message like this. And now you have to observe the return loss and VSWR plots of the dipole antenna. Just right click on results, create model solution data report, rectangular plot, S parameter dB. You can see. So operating frequency for this attack marker, to get approximately at 2.915 gigahertz, we are getting the return loss that is less than minus 10 dB. And just again click results, create model solution data report, rectangular plot, VSWR, units none. So we are getting approximately less than 2 VSWR. Okay. And just click results, create model solution report, 3D polar plot. Just click results, create far field report, 3D polar plot. Okay, gain total dB, and just click new report. You can see the radiation plot of the dipole antenna, gain plot. Okay, and this is the procedure to do the dipole antenna. Okay, thank you.